Hi, and welcome to this Blue Marble Geographic webcast. Today we'll be covering navigating the data source in Geographic Calculator. My name is Jeff Hatzel. I'm an application specialist at Blue Marble Geographics.
And I'm Scott Weber. I'm in the Quality Assurance Department.
Today we'll be discussing what the data source is and how we access it. And we'll be thinking about that both in the perspective of edit mode and through select mode, where we're selecting certain data source objects within a job. Within Geographic Calculator, the data source has its own menu. This drop-down menu contains options to access all the features within the data source. These would be things such as addressing ellipsoids, datums, and areas of use. We'll get into addressing coordinate system definitions in a little bit. As you'll see a little later on, many of these options are also accessible within a job when we're picking a certain transformation or when we're opening a certain coordinate system for a job. For right now, we'll go ahead and take a look at a coordinate system definition. So within the Edit Data Source window, we'll notice that on the left-hand side we have our folder structure. Here we have the ability to drill down through our data source in a variety of different ways. We could first look at all of our systems. We could view any recent systems that we may have searched recently, or view our search history. We have the option to look at fitted systems, which we'll discuss later, and even vertical systems can be accessed here. We also have the ability to search within a given folder. So if I were to highlight a certain folder, I could go down to search here and search for a given system. We'll now see that all systems with that name show up in our main window here, and I could further search into them as I needed to. To get a better feel for how we can navigate within the data source, we're going to look at a specific projected system today. In order to do that, I would navigate over to my projected folder. In this case, we're going to look at a UTM system, and we're going to do so based on the NAD83 datum. Scott, do you want to tell us a little bit about how this page is laid out?
Sure. So in the right-hand pane, there are several columns. You see there's an exclamation point there, and that is for systems that are not possibly loaded at this time. Sometimes systems need to be downloaded to put them there, so there would be a red exclamation there in that case. The lock tells you that it's a read-only definition. Everything that's from the main data source with the installation is read-only. In order to edit something like that, then we could make a copy of it, for instance, to make some edits. The third column indicates whether a system is deprecated. There is a preference setting that allows you to show deprecated systems. In this case, we don't see any, but they would be indicated in this column. Then there's the display name. That is a user settable name. In this case, we see that the display names look pretty much like the name column, but the display name is editable by the user if you choose to do so. The name column is the official name of the system according to the EPSG registry, or possibly some other registry that we include in the data source. Then we have the geodetic system upon which the projected system is based. In this case, again, it's NAD83. Now the datum column is indicating the datum that is used for the system, and here it happens to also be NAD83, but it's written out in this case. Then we have the units. All these systems are in meters. The type tells us the kind of projection that is used. In this case, it is a transverse Mercator. The next column is area of use. And if we make this window a little bit wider, it'll help us see the remaining columns, and we can widen the area of use to see that it shows the 6-degree longitude zones of transverse Mercator UTM systems. And that can help you figure out which system you need to choose based on the location of your data. Next, we have the dimension column. Here you'll see either two-dimensional or three-dimensional. And these particular projected systems are two-dimensional. Many of the projected systems are too. There are three-dimensional projected systems. The note I want to make here about the dimension is that just because it's a two-dimensional system does not mean that a z-value or elevation cannot be worked with in the calculator jobs. So two-dimensional systems are able to handle elevation data. The final column is the EPSG code. The EPSG, that is the European Petroleum Survey Group, and they're really the go-to source for the definitions of all these systems. Not every system in the data source is from EPSG, but the lion's share of them are. And these codes can be looked up. You can search on the code itself if you happen to know it, and they're your kind of a go-to reference to make sure that you're using exactly the right system, that you may be collaborating with somebody else.
Thanks, Scott. And so to get a little more in depth today, we're going to dive into a specific system here. In this case, we're going to take a look at NAD 83 UTM Zone 19 North. So right now, with the system highlighted, if I right-click on it, we'll see my right-click menu gives me a few options. I can copy an object if I want to make a copy of it. I can change its display name, as Scott told us the display name is customizable. Or I could add a new object to this folder as well. We'll notice that all these options have corresponding buttons down here, so I could access them via this route as well. In this case, we're going to go ahead and view the info for the system. So when we open the View Info window, we'll see that it defaults to the Definition tab. And we may want to take a look at identification first so that we can learn a little bit more about the system. We'll see the name here has the name listed. That's the predefined name for the system. Any remarks or notes about the system will tell us just a little bit more about it. And then we have some identifiers. So the EPSG identifier may stand out to you. We just discussed that. The GC one is the Geographic Calculator, what we use within the application. And then there's a few others here. Scott, can you tell us about those?
Sure. The first one, CS, that's an open source library alternative to the EPSG. And CS stands for Coordinate System. OGP URN is really just another way of referencing the EPSG. And then finally, SRID is the Spatial Reference ID. Now, the reason there are multiple identifiers for a single system is for compatibility among users or different versions of software.
And so, in addition to the identification for the system, we may also care about the history. This history will tell us any changes that may have occurred, when they have occurred, and what may have happened as part of that change. And so it just tells us a little bit more in-depth information about the system. As we get into the Definition tab, here's where we'll really start to dive into what components make up this system. So we'll see we have the projection name, in this case a transverse Mercator projection, and we'll see a variety of parameters that are associated with this system. We'll also notice the list of three objects up here: the area of use, the point style, and the geodetic. If we use the Info button here, we can open each one of these, and we'll take a look at the area of use first. The area of use opens a similar window to the previous window that we saw. It has, again, both an identification and history tabs if we needed to see any information there. The Definition tab now gives us even more information specific to this area of use. We'll see information about the bounding box, or the area which the area of use covers, so both its minimum point and its maximum point. If we wanted to view it on a map, we could click View Polygon here. This will allow us to see, where that zone is outlined on the map, and I can zoom in a little bit as I need. And so you might notice we also have one other feature here that we could see the info of, and this would be the point style. Scott, do you want to tell us a little bit more about point styles?
Sure. So the point style defines axes, generally speaking, and so we're in the area of use view right now. So if we click on the info box for this point style, we're going to see how the area of use is defined, and it's defined as latitude and longitude, and that agrees with, if we close this window, with those bounds that we see for the minimum and maximum points. And we'll talk more about point styles with the projected system and its underlying geodetic system as well. So now we're back out on the projected coordinate system viewer tab, definition. Now let's look at that point style. And here we're going to see, let's go to the definition tab, and we're going to see that the point style for the projected system, this UTM system, is eastings and northings in meters. Another object that we see underneath the projected system is its geodetic system, which is NAD 83. Again, clicking on the info, we can then see the information on that geodetic system. Again, an identification tab with all its codes, a history tab with any information we may want to see there. But let's take a look at the definition tab. And again, there we see an area of use, a point style, and the datum. If we click on the point style here, we're going to see now, under the definition, that we have a definition in geodetic longitude and latitude as opposed to eastings and northings in the projected system that overlies it. Okay, let's back out of the geodetic point style, and we see another object, datum. Let's take a look at that. The datum that underlies the geodetic system is also NAD 83. When we look at its definition, it has an ellipsoid, GRS 1980. And we can take a look at the parameters for this ellipsoid. We see the semi-major axis, the semi-minor axis, and the inverse flattening that defines the ellipsoid. And the prime meridian, which in this case is Greenwich, but there are other prime meridians that are used by other datums. Okay, so now we can back all the way back out to our projected coordinate system.
And so now that we understand the details of a system, we may want to think about the ability to copy a system. Copying a system will allow us to not only customize its name, but a variety of parameters about the system. And so as we saw earlier, if we right-click on a system, we can choose Copy Object. This will open the identification tab first. We'll notice the name now says Copy Of before the name of the system. Maybe I want to change that to Custom, so I know that it's a custom system. Under the Definition tab, I can change any parameters in here that I may need to. So let's say I'm working in a custom system that has its own false easting or false northing. I could adjust those values along with a variety of others in here. In this case, we don't need to make any changes, but we will hit OK. Now that this system exists, we can see it listed with all of our others, and we'll notice that it stands out because it's highlighted in blue. So anytime you see a data source object that's blue, that indicates that it's one that's custom. We'll see it has the custom name that I gave it when I was creating it. And this can then be treated just like any other predefined object in the data source, whether we want it to go in and view its info and all its details, or use it within a transformation in any given job. And now we're going to go ahead and look at navigating the data source from the perspective of doing so within a given job in Geographic Calculator. Here we're going to be prompted as to whether or not we want to save our changes, since we made a custom system today. In this case, we can really choose save or continue without saving, because we'll be prompted for a final save when we close out of the application. For right now, I'll just click save. So now we're back on the home screen of Geographic Calculator. we're going to go ahead and open an interactive job. And so the first thing I'll need to do when setting up an interactive job is to choose my source coordinate system, because the application is going to need to know for the point that I'm transforming what system that point is in. And so to get into our data source picker, I can double click on this first line here that says system. And this is going to ask me essentially, do I want to pick a system based on geographic area? And so if I wanted to, it would open a map, and on that map I could draw a bounding box of where I wanted to confine my search. In this case, I'm going to pick no. This will open the data source coordinate system picker. This window will look very similar to what we saw earlier. As you'll notice now, though, we aren't in edit mode, so I don't have the ability to have those buttons here where I want to add systems, and I can only view the system here, so I can't copy objects or do anything of that nature in this case. And so what we're going to do now is navigate to projected system. So I'll open my projected folder. We're actually going to go back into UTM, in this case into WGS84. And now I could search here if I wanted to and type in the name of the system that I was looking for. But in this case, maybe I'll just expand my display name and I'll scroll down to zone 32 north. So I can either single click on it and hit OK, or double click on the system there to select it. Once it's selected, we'll notice that we'll see the geodetic is populated from that choice, as are the units. If I wanted to change these, I could. For right now, we're going to keep it as is. And so we'll pick our target coordinate system in a similar fashion by double clicking on the system line. Again, we'll be asked if we want to do so geographically. We don't. We're going to be picking another projected system. It will be another UTM system, but in this case we're going to be choosing the ED50 datum. We'll be choosing the same UTM zone here since we are on the same place on the Earth. We want to make sure that we're in the correct corresponding UTM zone. And so once I've selected this, what this tells us now is that what we're going to be doing is transforming our datum from WGS84 to ED50, both of which will be in the UTM zone 32 north. Before I select my coordinate transformation, I have to enter the coordinates of my point. So I will first enter my northing value, and then below that my easting.
And Jeff, before we actually select the coordinate transformation, to illustrate how the filtering works on both the source and target as well as the area of use, if we can go back to the data source menu and look at the entirety of options for coordinate transformations from ED50 to WGS84, then we can see the difference. So we'll navigate to datum and Europe, and we can see that there are perhaps 20 or a few more coordinate transformations for Europe, and some of which are ED50, and lesser still, are ED50 to WGS84, which is our source and target in our interactive job. So there are this many transformations available, and now if we leave this edit menu and now select the coordinate transformation box, navigate again to datum in Europe, we see a much shorter list. So filtering has been done here based on two things, and all the transformations here are ED50 to WGS84, And also, all of these transformations have area of use boxes that contain the point that Jeff has already typed as the source coordinate. Now, one thing to note here, he selected one example. The bounding polygon around Great Britain here does not contain our point in Germany. However, if we open up this transformation and look at its area of use bounding box, the bounding box actually does contain the point. So those minimum and maximum latitudes and longitudes contain the point that Jeff has entered in the box, even though the polygon does not. There is an option in the administrative settings to filter based on these polygons rather than the bounding boxes. One last thing before we return to our interactive job is that our transformation is going from WGS 84 Zone 32 North, UTM, to ED50. You'll notice that our transformation names happen to be ED50 to WGS 84. That is of no consequence because the transformations are reversible. So just keep that in mind.
Thanks, Scott. Those are all great points. And so now that we're here, our list of systems is smaller, but we still need to figure out how we want to choose one. We can do that one of two ways, both thinking about our accuracy of the given transformation and its area of use. So Scott was explaining, why we see the Great Britain system area of use here, even though we're not in Great Britain. We may want to look, at our first system listed. It doesn't look like the area of use quite covers Germany, but if we look at our second system here, we'll see that this does cover Germany and France, and so that's probably the system which we want to use. I could either double click on this or hit OK here, and we'll now see the transformation name listed as the one that's going to be used for our transformation from WGS 84 to ED50. At this point, all I need to do is hit calculate, and we'll now see our target point has been calculated in ED50 from the original source of WGS 84. So that brings us to the end of what we were going to demo today. But from the skills we've learned as how we can navigate the data source both in edit mode and when we're selecting an object can be applied to any job within Geographic Calculator or any data source object you may need to navigate to.
If you have any questions about the topics we've covered in today's webcast or any other questions about Geographic Calculator, feel free to contact us at geohelp@bluemarblegeo.com. You can also contact sales at orders@bluemarblegeo.com.
Great. Thanks, Scott.
You're welcome, Jeff. My pleasure.